All right, Algebra 1, 11.1 is titled Measures of Center, and that's exactly what we're going to start with. A measure of center is a measure that represents the center of a data set. You know them as mean, median, and mode. In case you've forgotten, the mean of a data set is the sum, underline this, you know what part's important here, the sum of the data divided by the number of data values. The sum of the data, so that means I'm going to add all those numbers together and then divide by however many numbers there are. That's how you find the mean, also called the average. Now, I didn't know this until I looked here, but I guess apparently you can represent that as X bar, where they may say, if they call a data set X, they may say, put a bar over it, and that means find the mean of it. I've never seen that before, even in my math career. So I guess if you see that ever, you'll know that means mean, but you know, it's not going to be on your homework. It's not something that's very well known. Now, the next one is the median. The median of a data set is the middle number when the data values are in numerical order. Now, we talked about when we did that murder mystery, we talked about how if you have an odd number of numbers, an odd number of data sets, there will be one number in the middle. But if there's an even number, that means there's going to be two. So when the data set has an even number of values, the median will be the mean of the middle two values. So for example, if these dots up here represent my numbers, I just put 7 dots up there. Is there a middle dot?
No.
I can see a middle dot. Do you see it right there?
Oh.
There's 3 on, so this one right here would be the middle dot. There's 3 on each side. If I put an 8th dot up there though, so let me, again, this was the middle dot. If I put an 8th dot up there, now the middle dot that I just circled is no longer in the middle. Now it's offset a little bit. So now if there's an even number of data, there's 2 numbers in the middle. And what they're saying is if you're finding the median and there's 2 middle numbers because you have an even number of terms, find the average of the middle 2. Add those 2 middle numbers together, divide by 2 because there's 2 of them. That'll give you your new median, your middle, right? So if there's 2 numbers in the middle, find the middle of those 2 by averaging them together. And then finally, the mode. The mode is the data set, the value of the data set that occurs the most often. Whoa, that's pretty big. There can be one mode, no mode, and more than one mode. Okay. So you can have more than one. If you have 2 numbers that tie for the most number of occurrences, then you could have 2 modes, or maybe none of the numbers are repeated more often than any of the other ones. So there could be no mode. All right, let's go ahead and look at our first example. You'll need your calculators for this example. So go ahead and grab your calculators, get them out, unsheath them, or grab one of mine if you need to.
Dude, why are you extending?
An amusement park hires students for the summer. The students' hourly wages are shown in the table. How many students did they just hire? Yeah, they just hired 8 students. We know there's 8 students because there's 8 hourly wages up there. Okay, these are their 8 new employees. So we're supposed to find the mean, the median, and the mode of those wages. So the first thing we're going to want to do is line them up in numerical order. Number 1, because we have to do that for the median. And number 2, because it makes finding the other ones easier as well. So can someone please help me list these 8 numbers from least to greatest? And I'm gonna have to zoom in, which is why I'm gonna need your help because I can't always refer back to that list. What is the smallest number up there, Jude?
825.
Okay, what's the next smallest?
845.
Are you sure? 845 is the next smallest number?
8.45.
Is there,
there's 2. Oh,
okay, there's 2 825s. Okay, so we have to list them both. And then 8.45 was the next one, Jude? Okay. And then what comes after 8.45?
8.65.
8.65. Okay, so that's half of our numbers right there because I know that we have 8 of them. So I'm going to go ahead and scratch off the ones we've said so far, so we don't list them again. All right, now the next one. What's the next smallest number?
8.75.
Okay. Next smallest.
910.
Next smallest.
9.5.
And largest.
650.
1650. Okay.
I'm using that so I can get that.
Sure. All right, there the numbers are numerical order. What might be the most time-consuming part of this entire homework is lining them up in numerical order. The next most time-consuming part is actually calculating the sum of all those numbers. There are 8 of them. You go ahead and do that. Now, I don't want to know what you get after you divide. I want you to tell me what you get after you add them together. And I'll show you here in a second why I want you to write down this number and not just your answer. Tell me what you get when you add these 8 numbers together. And I'm going to need everybody in agreement here before we move on. Really, what'd you get?
77.2.
But what did you get before you divided?
77.2.
That's what you got after you divided. Oh, you said 77.2. Okay, sorry. That makes more sense. I'm not sure what I was thinking of. Probably the next example. 77.2.
Did you say my address when you were recording?
Sure. You want me to?
No, did you?
No. Did anyone else get 77.2? Lots of, okay. All right, I just have a bad memory. I was thinking something else. 77.2 is what you get after you add them all together. And then now, really, since you haven't divided yet, that was my mistake. What would you divide by?
8.
Yes, there are 8 numbers. Awesome. And what do you get when you divide 77.2 by 8?
9.65.
9.65. All right. So since these are wages, I'm going to go ahead and put a dollar amount. So the average or the mean wage is $9.65. Does that look accurate to you? Because it doesn't look accurate to me. And I'm not saying she's wrong. I think this is the mean. This is the mean. But if the mean is supposed to represent a measure of center, and I'm looking at $9.65, is it fair to say that most employees on average make $9.65 an hour? I'm seeing almost every employee make less than that, except for one. Let's find the median then. See if the median gives us a better number. Now, because there are 12 numbers, that means there's going to be 2 numbers in the middle. Still only one median though. I just have to average those middle 2 numbers together. My middle 2 numbers are going to be 8.65 and 8.75. And that's because when you scratch off 3 from the left and 3 from the right, those are the 2 that are left in the middle. So when I have 2 middle numbers, again, I add them together and divide by 2. What do you get for the median, Addison?
When you add them up, you get 17.4, but when you divide by 2, you get 8.7.
Perfect, 8.7. And if we're talking about money, we'll go ahead and add an extra 0 and say $8.70. Yeah, and that makes a lot of sense too. So she said what she got when you added them together and then she divided by 2. It also just makes sense that you would find 870 right between 865 and 875. Okay, it should be right in the middle. And then do we have a mode? Because it's possible to not have one. Maddie, what is the mode?
It's 8.
Perfect. They've got 8.25 repeating twice. It's the only one that repeats. So our mode is going to be $8.25. Another reason why I like to line up the data first is because it does make even finding the modes easier to do because they'll be right next to each other. Okay, so next question, because you've done that before. Which measure of center best represents the data? Well, let's go back to the mode that we just talked about. Even though the mode occurs twice, I don't think it's fair to say that most people are going to make $8.25 because that was the lowest end of the spectrum, right? But as we just mentioned with the mean, I don't think $9.65 is a really good estimation of how much you're going to make because nobody except the person who made a lot more was making $9.65 an hour. Or we said these 8 employees. That leaves us with the median. If I said $8.70, I think most people would find that a fair estimate because it is right in the middle, where the average is supposed to be. So the best measure of center for this data set is going to be the median, because it's in the middle. But why? Why is the average so much different than the median? Hannah? Because there's an outlier. You're exactly right. And what is our outlier, Hannah? Yep. One of these new employees is making basically twice what everybody else is making. And I'm not sure what their job is. It must be more difficult or must require more work. But whatever they hired this student to do, they're getting paid almost twice as much as everybody else. That is our outlier. And what that outlier is doing is it's dragging the average or the mean up because the outlier is bigger than the rest of the data set. It's dragging the average up. If you look at the average, $9.65, that would fit right there in with our data, right between 925 and 1650. That is not a good number. That's not a good average. That's not the average of my data. Now, it is the average, but it's because the 1650 is so much larger than the rest of the numbers that it's dragging the average up from where it should be to where it currently is. That's what an outlier will do. So if the outlier is present, we're going to not want to use the mean because it's going to be off. Okay, it'll throw that mean off. Okay, so your answer for B, the median, and why? Because there is an outlier. Because there is an outlier. So what is an outlier? Well, the actual definition of an outlier is a data value that is much greater or much smaller or much less than the other values in the data set. You guys have talked about outliers before. In this last example, Hannah said the outlier was $16.50. So here's what they want us to do now. How does that outlier affect the mean, the median, and the mode? So we're going to do this all over again without the outlier. That's why I had you guys write down to 77.2, because instead of adding all these numbers up again, if we know that they all add to 77.2, we can just take away the 1650 from that, and that's what we would have gotten before the outlier. So I'm just going to copy that down. In fact, I'm going to copy all this. Go ahead and copy all this stuff right here. I'm just drag this all down. With the outlier, the mean was $9.65. The median was $8.70. And the mode, which is now off my screen, there it is, $8.25. Now we're simply just going to erase the 1650 like it was never there. And recalculate. I'll give you guys a second to tidy that up a little bit. I just copied and pasted everything we'd written already. The 77.2, if we take away the 1650, is going to be 16.50 smaller. So what's the new total that we're going to get, Natalie? 60.7. Yeah. Now that's why I wanted you guys to write down what we got when we added them together. And that's why on your homework tonight, I think it's going to be also a really good idea to write down what you get when you add them all together, because you know the next questions they're going to ask you is how is the outlier affecting it? And so you have to then take away. It's so much easier just to subtract one number away from our total than have to add all 7 numbers together again. So our new total is 60.7. If the outlier is no longer there, it was here, now it's gone. If the outlier is no longer there, how many numbers do we have in our data set now? 7. So we're going to take 60.7 and we're going to divide it by 7 instead of 8, because now the outlier is gone. Branson, what is 60.7 divided by 7? 8.671. And we'll just say 8.67 because the 1 does not round the 7 up. And since we're talking about money, we only want to use 2 decimals places, 2 decimal places, I should say. That's a pretty big change. Now, because it wants to know what the effect was, I need to know how much, not including the outlier, brought the mean down by. So I want to know the difference. To go from $9.65 to without an outlier, now going to $8.67, how much did it change our mean by? How'd you get 98 cents? Just subtract it. Yeah, just find that difference. So that's an effect of 98 cents. That's almost a whole dollar an hour that our mean went down without the one person who made the $16.50 per hour present. Okay, now let's recalculate the median. Remember, our old median was $8.70 because it was between these two, right? Now, because there's only 7 and 7's odd, there's not going to be 2 numbers in the middle. There'll just be 1 number in the middle. What is that 1 number in the middle? Yeah, 8.65 will be our 1 number in the middle. So our new median is just $8.65. How much did our median go down by? Only 5 cents. So remember in the last problem, it said, which is the best measure to use when there's an outlier present, because there was. We chose the median because the outlier only had a nickel change on the median, but it had almost a dollar change on the mean. What about the mode? What did the mode change by? What is the new mode? Didn't change at all. It's still going to be $8.25, and there was no change. So you might be thinking, well, why not use the mode as my best measure if it's never going to change from the outlier? The reason for that is because the mode doesn't always give us that center number. In this case, our mode is the 2 smallest numbers that are repeating. Typically, you only want to use the mode if you're voting for something, or if there's a reason why you want to know what number occurs the most. If you just want to know what number's in the middle, the mode's not necessarily going to tell you that. The mean or the median will. The mode's just going to tell you which numbers occur most often. Could be close to the middle, could be, and this problem, close to the bottom. All right over there? All right. It says which measure of center was affected the most by the outlier? The mean was affected the most. That is not a coincidence. That will always be the case. The outlier will always have the largest effect on the mean. So how do I know what my measure of my best representative measure is? Is it going to be, I know the mode is only used if I'm, calculating a vote or something, whichever one was voted on the most. So it's either going to be the mean or the median. How do I know which one to use? It comes down to whether there's an outlier or not. If the data set does not have an outlier, your mean is the best one to use because it'll be in the center. Usually we want to use the average. In fact, Skyward, when I look up put in your test grades, it's going to tell me what your average is. What if I put all your test grades in and somebody wrote the answer porcupine for all of their answers? They're going to get a 0. And so what's going to happen to the class average if I put all your grades in and then a 0? It's going to bring it down. But if I use the median, it wouldn't have had that much of an effect. Okay, so mean's great, assuming there aren't any outliers. But if there is an outlier, you're going to want to ignore that outlier, and then you want to use the median. So if the data set does have an outlier, use the median. And if you think about that, why is the median affected the least? Or other than the mode, why is it affected the least? Because the outlier, when you line your numbers up from least to greatest, is going to be either the much smaller number that's listed first, or the much larger number that's listed at the end. And what do you do when you start finding median? Scratch off. It's like one of the first numbers you scratch off. So yeah, it's going to be shifted by a number, just a little bit, 5 cents in our last example, but definitely not as much as the mean is affected, which is almost an entire dollar. Look how close, I didn't mention this in the last class. Look how close without the outlier, the mean and the median are. They're only 2 cents off now. That's good. That's what we're looking for. We want them to be close together. They're supposed to both be in the center. They should be pretty close to each other. Here it was much wider gap. All right, here's our next part of the notes. A measure of variation. A measure of variation is a measure that describes the spread or distribution of the data. It doesn't tell you the numbers that are in the middle. It tells you how widely spread out they are. We have the most common measure. There is more than one, but the most common measure of variation is called the range. Typically, when we do mean, median, and mode, range always gets tagged in there. It's not a measure of center. It's a measure of variation, though. It tells you how spread out your data is. And so one measure of variation is the range. And to find the range of a data set, you have to find the difference of the greatest value and the least value. Now, what does difference mean? Subtract. I take the largest number and subtract the smallest number. Let's look at our next example. 2 reality cooking shows, select 12 contestants each. The ages of their contestants are shown in the tables. Find the range of the ages for each show. Why don't we start with show A? I'm not calculating mean, median, and mode right now. I'm just doing range. Maddie Cheeseman. In show A, who is the oldest contestant? How old are they? There is a 31-year-old. That's the oldest contestant we have. Okay, so I take the 31-year-old and I subtract away the youngest contestant. Who's the youngest one, Maddie? Yes, 19. One of the Maddies. So the range is going to be the largest number minus the smallest number. Andrea, what is the range for our show A? 12. Yeah, so that's a difference of 12 years. From the oldest contestant to the youngest contestant, it's just a difference of 12 years. Now let's do show B. Caden, how old is the oldest contestant in show B? 48, okay. And how old is the youngest one? 19 again, okay. So this is going to have a wider range. Alexis, how wide is that range? What's 48 minus 19? $29. So which show had a wider range of ages? Definitely show B. Why did show B have a wider range of ages? What's different about show B? Because that's a big difference. The range is 17 years wider in show B. Why is that? Really? You don't know? You're going to be the only class today that doesn't know the answer to this then. Even period 1, who's hardly awake, knew the answer to this. Jude, what do you think?
Is it because show A is like the main show, and show B is like the A team and B
Are we
team?
overthinking
Nope.
this?
Yep. Andrea?
Show B has 48.
That's right. What do we call that number? An outlier. Show B has an outlier. Yeah.
It's kind of like in like second show, yeah.
Yeah. It's because of the outlier there. Yeah. So in show A, they didn't have an outlier. The youngest to oldest contestants were only 12 years apart. Most people were in their 20s. We had a 31-year-old, we had a 19-year-old. And show B, again, most people are in their 20s. We have a 30 and 31-year-old. And then we have this, a 32-year-old in show B. Sorry about that, 32-year-old. And then we have that 48-year-old. That 48-year-old is 16 years older than the next oldest contestant. That makes them an outlier in show B. And so what that wider range does, that wider range can be an indicator we might have an outlier here, because that's a pretty wide range. So the last part of our notes today then is says compare the mean and the median of that show B, the one with the outlier, with and without the outlier to see how much it's affected by. So for show B, there are 12 ages up there. Could I have a different volunteer to help me list these in numerical order? Thanks for volunteering, Natalie. Natalie, what's the smallest age in show B? 19, next smallest, next youngest. 20, next youngest. Next youngest. Next youngest. Okay, that would go before the 22. That's all right. That's why I like notability. I just slide those over. 19, 20, 21, 22, 22. What comes after 22? 24. Okay, so that's halfway done. We have 6 numbers. We need 12. 25 is the next one. What's after 25? 25 again. Okay, so I see a mode, look, a couple modes there. What's after 25? What's after 27? Oh, no, 3 modes. There are 3 modes in this one. And after 27? And after 32? And that's our outlier. The outlier is either going to be the smallest or the largest number of your data set. So I've got them lined up from least to greatest. The next thing is to add them all together to find the mean. Now, just like last time, because you know we're going to have to then take away the outlier. Instead of adding all 12 numbers up and then adding all 11 numbers up the second time, why don't we just write down what we get when we add all 12 numbers together? Go ahead and take a moment to do that. What do you get when you add all 12 of those ages together? Addison. 312. Okay. Need a lot of more people to confirm that before I do all the work. There's one person confirming you. 2 people, 3 people. Hunter, you got 291. You got 290.
I got 290.
I don't know. Why is it not back there, dude? Bring on, no. Bring it on up here.
Really?
Yeah, you had your chance.
Okay. I'm sorry. My alarm's not even on.
Hunter, I'm thinking you and Jude both forgot a number because I'm seeing multiple people say 312. You got 312? We'll go with 312. So, and that could be as easy as forgetting a number or just hitting something wrong with our calculator. This is my least favorite part of finding the measures of center, is adding all of them together for the mean, because there's so much room for error right there. So we get 312. There are 12 numbers. So we're going to divide by 12, and that'll give us the mean with the outlier included. So divide by 12, Addison. 26. Okay. Now 26 is not quite in the middle, and that's because of the outlier. I want my mean to be in the middle, but it's not quite there because it's been affected. So if we take the mean away, I'm sorry, take the outlier away, basically take the 312 and subtract away the 48 that we added onto it for the outlier. And what is our new total? Someone new, someone I haven't heard from yet. Ella, thanks for volunteering. What's 312 minus 48? Okay, so if you don't add the outlier onto our data set, it only adds up to 264 now. Also, there are 11 numbers instead of 12 if I don't include the outlier. So Ella, what's 264 divided by 11? 24. And that's a change of how many years? Yeah. Not including the outlier brought our average age down by 2 years because of the 48-year-old. I'm not saying there's anything wrong with 48-year-olds, but it was a bit different to see them on show B, right? All right, now for the median. When there's 12 numbers, so we're back to including the outlier again. When there's 12 numbers, there's 2 numbers in the middle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's 2 numbers in the middle. When you have 2 numbers in the middle, you average the middle 2 together. What number would I expect to find right between 24 and 25? Anna? 24 and a half. That's exactly right. But if I take the outlier away, now there's only 11 numbers. And so I need one more scratch on this side to make it even. If there's 11 numbers, 11's odd, there's gonna be one number in the middle. Now it just went down to 24. That's a change of how many? 0.5 again. So you can see not only is the outlier not having that much of an effect on the median, but when you take the outlier away, look at this. Without the outlier, the mean and the median are the same number now. They're not just close, they're exact. That's what an outlier does. It changes it from being 1.5 years apart to being very, very, very close. So let's recap real quick. If you have an outlier, do you want to use the median or the mean? The median. If you have an outlier, because it's not really affected by the outlier. If you don't have an outlier, hey, stop moving around and listen. If you don't have an outlier, which one do you want to use? The mean. I'll say that again because I don't think we all got that. If there's an outlier, use the median. If there's no outlier, use the mean. This will probably come up on your iLearn test next week. Keep that in mind. Okay, now you know which one. They may ask you how much it affects. You can calculate that, but now you know what you're looking for. You're looking for it to affect the mean. All right, that's it. Your homework, some big ideas tonight. Jude, you can get your phone back at the end of the day.
Okay, can I turn off my other alarms because there's one set for 9:30 and 10?